1979, being French was not very serious in the small world of F1. Certainly, there was Matra and the famous MS-80 world champion, but this exceptional car, the Froggies, had had the intelligence of entrusting it to Ken Tyrrell, the most English team manager, and his team of English mechanics as well.
What had become of this team who designed the Matra MS-80 in 1979? Bernard Boyer had pulled away from the cars, and at Ligier, we found some of his collaborators, starting with Gérard Ducarouge, the head of the Three Winds, at Le Mans in endurance. He is not the only one. Paul Carrillo and Yo-Yo Hublet. All this means that any experience acquired by a racing service over the years has not been lost, as we shall see later, and allowed Guy Ligier to build his own Formula One cell.
However, in Argentina, at the first Grand Prix of the season, the proof of the pudding, as they say, was in the eating. The Ligiers occupied the front row of the grid after tough qualifying sessions.
Ground effect was the last revolution caused in F1 by Colin Chapman. In 1979, everyone understood this and got involved. The family resemblance between the JS11 and the 05, 07, and 09 comes from its front end and, above all, from its livery. In fact, the first thing one notices is its wide, very thin front wings framing a steep and massive nose. It widens at the level of the front suspension, fairing in the rocker arm shafts. This prominent section, perfectly designed from an aerodynamic standpoint, is explained by Gérard Ducarouge's desire to avoid overly long rocker arms. The cockpit ends in a pointed fin. This small tail, which encloses the roll bar and hides all the filling orifices, is the perfect aerodynamic complement to the driver's helmet quorn. The airflow brushing the helmet of the driver converges and, without turbulence, passes over the Cosworth DFV powering the JS11. The engine's intake trumpets, simply covered with an anti-gravel mesh, can draw in non-turbulent air and feed the engine efficiently. Aerodynamics clearly dominate the entire design of the JS11. It is a tribute to the work of engineer Choulet of the Eiffel Wind Tunnel, who designed this bodywork, showing the great care they put into drawing and developing it. The big piece, the major innovation of the JS11, lies in its side pods. Michel Beaujean explains.
This is the wind tunnel. We had really done a lot of work. Moreover, the corollary of ground effect at that time was to have the possible sealing mesh under the car so that this suction effect that stuck the car to the ground like a suction cup occurred. This waterproofing was generated by a system of mobile skirts under the car, on its periphery. It wasn't easy. We had to understand the principle and then understand how to do it so that this tightness does not disappear in the middle of a curve. It was very dangerous. We had mounted the skirts in cassettes, with small needle bearings that were 1/8 in diameter, in several rows. The skirt itself, with the runners on the ground side, was guided along the entire length by these little bearings. It worked wonderfully. But what an implementation! The skirts were in contact with the ground all the time. Vertically, there was practically no friction thanks to the Giel bearings. We had put elastic ribbons that pressed them to the ground. For the record, those who had been put on at the start were not stiff enough. I spent an afternoon in Buenos Aires the week of the Argentine Grand Prix to find the right ribbons and therefore the right solution. The skirts were made of Nida. At their base, to protect the skirt and rub in its place on the floor, there were ceramic pads. These ceramic barrels were glued into aluminium tubes taken from the base of the skirt. The whole problem was to obtain maximum waterproofing, so to rub but without wearing it out prematurely. We ended up finding the right compromise so that the ceramic would not fall apart and last for the duration of a Grand Prix. It was quite an adventure, the skirts. It kept us busy for hours and hours. It quickly became clear that the ceramic they were made of did not last long enough. They have been replaced by much more resistant metallic oxides of alumina or tungsten. It was so dangerous. If there was one that stayed open in the corner, it was the big crash, because you had to see the transverse forces that the pilots were taking at the time. We had reached the human limit. They even had to strap their helmets to the top of the cockpit to make it bearable.
Seen from the inside, the front of the right-hand side pod shows the angled location of the radiators. Seen from the front, the rectangular openings cut into the downforce generating planes have no aerodynamic role. They only serve to scoop air for the water and oil radiators. The air warmed in this way exits through the top, channeled by 3 adjustable deflectors so that mischievous vortices do not interfere with cooling. This system has given complete satisfaction. At the front, the notch designed to house the oil and water radiators, then the 2 reinforcements used to attach the side pod to the monocoque. The grid pattern on the upper surface consists of carbon fibers to strengthen the whole assembly. On the outer edge, one notices a small ridge that begins at the start of the wing stub and ends at the rear shark tail. It is simply the visible emergence of the double wall containing the movable skirts, which are pressed against the ground by springs and rubber elements. It is rigid enough to prevent the skirts from fluttering, and, thanks to its small upper crest, it improves the anti-yaw aerodynamic guidance. The rear profile of the side pod is one of the major original features of the JS11. The upper part of the wing is divided longitudinally into 2 strips. The one closest to the cockpit continues horizontally and will be extended by an engine cover. The outer section rises sharply, while the outer plate forms that famous shark fin, a vertical stabilizer that, just like the rear wing end plates, ensures the car's longitudinal stability. As for the small spoiler it supports, it provides many benefits. Its upper surface, deeply inclined, is a mini-wing with a very high angle of attack. It improves aerodynamic balance since it tends to move the famous point F backward toward the car's center of gravity. Like any deflector, it acts on the airflow, directing it toward the rear wing. But its main function is to evacuate the air previously trapped under the venturi. Indeed, a large part of that space is occupied by the engine exhaust. Air builds up in front of the curved pipes, reducing the overall efficiency. Fortunately, the outer section is free, and this deflector allows the air to be properly expelled above the wheel. What level of depression can these side pods generate? A quick, very approximate calculation shows that it is enormous. At 200 km per afterbalance, downforce should reach 2,600 kilograms. If everything worked, as in the textbooks, it would be far too much. The suspension, springs, and components would need to be excessively heavy. A number of leaks and various turbulences must reduce it by half. At top speed, around 300 km per hour, the wind speed under the side pod more than doubles. The car is literally sucked toward the ground. At high speed, the work of the skirts becomes essential. To prevent them from moving sideways, they are firmly attached to the side pod and, at the rear, to the engine via a stiffener.
We had masked the car's performance a little during winter testing at Ricard. People were saying, but how did you do your times? And we would say, that's because we had qualifying tyres and low fuel. A more than usual argument at Ricard, but more to mask poor performances than exceptional performances. When we left for Argentina, we only had one car, the Mule. The 2 racing cars were 2 chassis and boxes of parts, but we put everything together during the week of the race by sleeping 1 hour a night.
In Argentina, Jacques Lafitte was not very satisfied with his handling. After describing it to Ducarouge, it was up to him to find a solution. Without too much trial and error, Ducarouge had large aluminum deflectors built, which were riveted under the side pods, with their ends hastily attached to the exhausts. One can clearly see the aluminum plate fixed under the side pod and running beneath the exhaust.
The Ligier JS11 model is of golden era slot cars by Kostas Zingovic in Thessaloniki, Greece. It has a great level of details and runs very well on the track, on par with its polycar pairs.
The chassis is 3D printed. The motor is a slimline 19.000 RPM and the wheels are made of aluminum. The motor mount and gears are from Polycar and the guide is slot.it1.
Most of the car parts are 3D printed in resin. The weight of the car is 74.6 grams.
So, the Ligier secret? It is not only in the visibly refined and successful aerodynamics, there is something else, the mechanics. In 1979, the famous Matra V12 has become a museum piece just as the best Ligier chassis was coming out of the Brest workshops, a paradox and a cruelty of racing. The V12 won only a single Formula One World Championship Grand Prix. Now the Cosworth DFE sits in the chassis of the Ligier. Fortunately, it is not the first time. The JS03 and JS04 had already used the DFE in endurance specification and had solved the problem of vibrations generated by the flat crankshaft. These vibrations should not be underestimated, as some Formula One cars have been seen to break in two at the mounting points. This compact, tightly packaged 90 degrees V8 of 3 liters produces only 480 horsepower at 10,800 RPM, which is far below the Ferrari, Alfa, or Matra 12 cylinders, all closer to 520 horsepower. On the other hand, its weight, 175 kilograms, its lower fuel consumption compared to its rivals, and its torque of 35 millimeters at 8,000 RPM keep it highly competitive. Moreover, it is the only engine available on the market, and its price, 140,000 francs, is one of the lowest. This arrival of the British engine supplier was sometimes poorly received by the French public. Ligier is criticized for no longer racing with a French engine, but what could he do? The gearbox is a Hewland FG400 with 5 or 6 speeds plus reverse. It is universally adopted by all those who use Cosworth engines. All attentive observers have noticed the exceptional traction of the Lotus in corners. It has been murmured that they had a highly sophisticated rear axle, far more efficient than the classic limited slip differential used by everyone. The secret, if there is one, has been well kept. The JS11 seems just as effective as Chapman's car in the slow sections of circuits. Certainly, everywhere else they are on equal footing with their rivals, but they gain a decisive advantage in acceleration after tight corners. From there, it is tempting to conclude, just as with the Lotus 79, that the JS11 has something new in the differential area, especially since the Hewlands are being seriously reworked in Vichy, including the casings, which are modified and reinforced to better accommodate the rear suspension. Does this increased rigidity allow less power loss in the transmission, or do these Ligier casings conceal some major innovation? Gerard Ducarouge is even more discreet on this subject than on his downforce-producing side pods. In terms of handling, all the experience accumulated with the JS05, JS07, and JS09 is found in the 11, which was visibly built with great care. This tradition of quality is one of the constants of the Ligier team. The monocoque, made of riveted duralumin, is reinforced by no fewer than 6 frames made of special steel. The aluminum for the sheets, steel for the reinforcements has now become a Vichy classic. So has the weight, considered excessive by some, of the Ligier monocoques, a good 20 kilograms more than the competition. These kilos must be recovered elsewhere on the car through extensive use of titanium, springs, spherical joint housings, transmission parts, stiffeners, etc. According to Gerard Ducarouge, rigidity comes at this price, and he readily recounts how the monocoques of certain competitors finish races terribly deformed, something that will never happen with the JS11, solid as a rock and providing its suspension with fixed, reliable mounting points. The need to clear space for the side pod led the design team, Paul Carrillo, Michel Beaujean, and Gerard Ducarouge, to push the steering wheels outward. Thus, the front track increased from 1.5 meters on the JS05 to 1.6 meters on the JS09 and reached 1.7 meters on the JS11. The rear suspension is highly original, made necessary by the constant concern of leaving a clear path for airflow. As at the front, the upper pivots are placed very far from the monocoque, while the lower ones almost meet under the gearbox. At the top, there is a triangular, fabricated rocker arm pivoting on a very long axis. This wide base and the rigidity of the part allow it to transmit forces from the hub carrier to the monocoque. Beyond the axis, the second part of the rocker is angled, acting on an almost vertical spring damper unit cleverly placed along the gearbox, between the engine and the brake discs. The rocker arm actuates, via a link and two large levers, a very short anti-roll bar mounted on the rear crossmember. This robust assembly is not adjustable. A second bar placed immediately behind it handles that task. The easy access to this link makes toe-in adjustments simple. It rests on a particularly strong fabricated hub carrier. This component is guided at the bottom by a simple but particularly sturdy wishbone whose arms are faired. Here, everything must be done to promote air evacuation, which explains this entirely new but very effective geometry.
The JS11 performed well straight from the drawing board. During its first test on the Paul Ricard circuit in December 1978, she had done breathtaking times. French observers didn't want to believe in it too much, since in 1976, the JS5 had shattered records during practice to take only the 8th place in its first Grand Prix. During winter testing, the JS11 worked great in the corners, but dragged himself in straight line. The team had gone too far in the dependence. No more time to redo a wind tunnel test program before the departure for Buenos Aires, then Ducarouge tinkered with an aluminum plate to modify the Venturi. Ligier went to Buenos Aires with 3 new cars, a mule that has already participated in rain-shortened testing, and 2 almost identical frames, which have never completed a single lap before. In the tests, some problems with the springs that pin skirts to the ground. A gearbox seized on the mule. Lafitte will be the main victim on Thursday and Friday, but makes up for it on Saturday with a lap time which leaves the first Lotus more than 1 second behind. In the race, Lafitte will have no problem, but Depailler will be slowed down by his brakes and an engine problem of electrical origin and will be forced to stop at its stand, an unfortunate decision that will cost him the 2nd place. The main system of springs had not been satisfactory at first. Gerard Ducarouge mounted rubber bands in place of the metal springs, but he didn't have time to make an endurance test. It was therefore to be feared that during the race the Ligier would lose progressively the efficiency of their skirts, which would have cost them a good second per lap. Fortunately, it was not the case. The skirts of the 2 JS11S worked very well to the end.
True, but when the flag drops, it's Depailler who makes the better start from this historic front row for French motorsport. Lafitte, however, soon eases past into the lead.
Since the Ligier JS11S have been running, never has there been so much attention around the cars. Engineers, team managers, and drivers shamelessly crouch down and lift the skirts of the beautiful lady. From Argentina onward, the sharpest minds began manufacturing Ligier-style side pods. Others rushed back to Europe to do the same and test them in the wind tunnel for confirmation. Nothing would help. It was the legendary 1-2 at Interlagos, with 2 unleashed drivers, Jacques Lafitte never letting Patrick Depailler out of his sight meter by meter, yet both far ahead of their pursuers. Technically, nothing to report. Happy teams have no stories, only a great exhaustion that collapses even the strongest as soon as the nervous tension fades.
Depailler would start in 2nd place, Lafitte starting once again from pole position.
Magnificent 5-mile Interlagos circuit, and on the front row of the grid, fastest of all, number 26, Jacques Lafitte in the magnificent Ligier. Alongside him, his teammate Patrick Depailler. Then in the second row, on the left, Mario Andretti, the world champion in the Lotus 79. His teammate alongside him, number 2, Carlos Reutemann. Then the 2 Ferraris, Jody Scheckter in his first year in the Ferrari team, and number 12, Gilles Villeneuve. Then Pironi in the Tyrrell, Jabouille in the Renault, James Hunt and Fittipaldi. And now, 40 laps, away they go, 200 miles, straight into the lead. Jacques Lafitte, followed by Reutemann and Patrick Depailler. Now, round curve 2 and into the long straight, and it's Jacques Lafitte leading Patrick Depailler, with Reutemann alongside him, Andretti in the middle. On the right is Jody Scheckter, and Andretti cuts through on the inside to take third position. Niki Lauda in midfield in the Brabham Alfa Romeo, and Jacques Lafitte already on the first lap out of this 40-lap race, is pulling away from his teammate Patrick Depailler in second place. It looks as though the Ligiers are doing it again. The Lotuses are third and fourth, Andretti and Reutemann. Lafitte is on his way and coming down towards the end of the first lap. One lap completed then. Jacques Lafitte in the Ligier across the line, and already he's setting the pace of the race from the very front. Behind him, Depailler second. No change at the front, and it doesn't look as though there's going to be one, because the Ligiers are very reliable. And there is Lafitte on lap 16, coming up to take and lap Clay Regazzoni after the Swiss driver has spun and regained the circuit. Patrick Depailler tucks in behind the white Williams. And Lafitte has put in a record lap at 2 minutes, 28.7 seconds, 6 seconds faster than the lap record. But it's still Jacques Lafitte's race all the way, looking very cool and totally effortless, and totally too dominating the race from the front. Jacques Lafitte wins from his teammate Depailler, Carlos Reutemann in the Lotus third, Didier Pironi in the Tyrrell in fourth position, Gilles Villeneuve Ferrari in fifth place, and the last World Championship point scorer Jody Scheckter in the Ferrari. But the worry for the whole Formula One circus from now on is Jacques Lafitte and the wonderful Ligiers. Jacques Lafitte leads the World Championship, 18 points. Then Reutemann and Depailler second and third. John Watson, the top British driver, Didier Pironi in fifth position, and tying for sixth, Gilles Villeneuve and Mario Andretti with a mere 2 points.